Our galaxy alone has trillions of planets. The observable universe has trillions of galaxies. It's estimated to be about 2 trillion. So trillions of trillions. Come on. The James Webb Space Telescope has revealed around 15 extraordinarily ancient galaxies, pushing us closer than ever to the dawn of the universe, and igniting a renewed race to find the very first galaxies that ever formed. Somehow, gravity wasn't thermalized with everything else. And that's something which needs to be explained. To me, it's the greatest puzzle about the Big Bang. Since its launch, the Webb has delivered discovery after discovery that has left scientists stunned, forcing researchers to rethink long-held assumptions about the early cosmos. It never gets dull with the Webb. This telescope is a technological marvel and one of the most transformative scientific instruments ever built. These newly observed galaxies, surprisingly well-structured and astonishingly mature for their age, don't just set new distance records. They challenge our standard models of how quickly galaxies could have formed after the Big Bang. Since the summer of 2022, headlines have poured in one after another. Galaxies that seem too early, claims that the Big Bang is in trouble, and suggests that cosmology is facing a crisis. But what's really happening behind the scenes, and what should we realistically expect next? The truth is, the Webb mission has only just begun. So far, we've captured only a small glimpse of the early universe, essentially a single snapshot. As observations continue, we may soon encounter even more startling phenomena. Unexpectedly massive black holes forming very early, galaxies growing at breathtaking speeds, and cosmic structures that strain the limits of current physics. For decades, we've believed the universe is about 13.8 billion years old and began with a hot, dense expansion we call the Big Bang. That framework still holds, but it was never free of open questions. Now, with the Webb's unprecedented data, subtle inconsistencies are coming into focus, uncertainties in distance measurements, refinements to cosmic timelines, and clues that our picture of the universe's earliest moments may need adjustment. In many ways, the James Webb Space Telescope isn't starting a new debate. It's bringing a long-running one back into sharp focus. As technology has improved, our estimates of the universe's age have become increasingly precise. Yet for those who followed the details closely, there has always been a lingering sense that some conclusions rest more on interpretation than certainty. The estimated age of the universe has been revised multiple times before settling on the now familiar figure of 13.8 billion years. Webb's observations don't simply overturn that number, but they do reopen uncomfortable questions about how confidently we can measure cosmic distances and timelines. At the heart of this discussion lies a key concept in modern cosmology: redshift. Redshift describes how light stretches toward longer, redder wavelengths as it travels through space. Traditionally, the amount of redshift observed in a galaxy's light is interpreted as a measure of how fast that galaxy is moving away from us, and therefore how far away it is. This idea has long been one of the central pillars supporting the theory of an expanding universe. But now, redshift itself is under renewed scrutiny. The Webb's unprecedented sensitivity raises the possibility that we may not fully understand how light is altered as it journeys across billions of years. Dust, gas, and other forms of interstellar matter could subtly affect light along the way, shifting its color in ways that are more complex than our models currently assume. Interestingly, this is not an entirely new concern. Nearly a century ago, Swiss astronomer Fritz Zwicky proposed an alternative explanation for redshift. He suggested that light might gradually lose energy as it travels through space, a process he referred to as tired light. In this view, redshift wouldn't necessarily be evidence of cosmic expansion, but rather the result of light interacting with matter or radiation fields over vast distances. Zwicky's idea never replaced the expanding universe model, but it also never disappeared entirely. Now, with the web providing data of unprecedented depth and clarity, scientists are once again being reminded that even our most trusted assumptions deserve regular re-examination. Put simply, this would mean that the source of the light and the observer aren't actually moving away from each other. If that's true, then the idea that the universe is expanding starts to fall apart. And once expansion is gone, the consequences are enormous. First, space itself would no longer be stretching outward from some original starting point. That would also strip away the foundation of the Big Bang as we currently understand it. And with it, our familiar ideas about how the universe might one day end. Right now, most proposed endings depend on expansion. The Big Rip imagines the universe expanding so violently that even atoms are torn apart. The Big Freeze suggests expansion slowly drains all usable energy, leaving a cold, lifeless cosmos. The Big Crunch predicts expansion eventually reverses, causing the universe to collapse back in on itself. Each of these scenarios assumes expansion is real and fundamental. But what if it isn't? In that case, we might be living in an infinite universe, one with no clear beginning or end. Or perhaps we exist inside a bubble universe, or even within a higher dimensional reality, where our familiar three dimensions are just a tiny slice of something much larger. With our current physics, we may only be capable of describing a small fragment of the full picture that naturally raises an unsettling and exciting question. Will we ever truly know the age or size of the universe? Right now, the honest answer is that we don't know. It's entirely possible that new layers of reality will keep revealing themselves, pushing any final answers permanently out of reach. History reminds us how often certainty gives way to surprise. 500 or 600 years ago, many people believed the Earth was flat. Even trained astronomers once thought the sun revolved around our planet. Each time, deeper observation reshaped our worldview. We can see 13 billion light-years into a universe that never ends and keeps surprising us with new things. People who want solid explanations and proof will be let down. But James Webb will give you a lot of new information if you like new things and mysteries. In the summer of 2023, Canadian researcher Ragendra Gupta came up with a theory that the universe could be 26.7 billion years old, or even older. His math is based on new discoveries, Zwicky's idea of tired light, and a change in the cosmic constants. The design has already been tested and works as expected. But this doesn't mean that Gupta has found the truth. We will only find it by looking. Think about how James Webb is still showing us older galaxies and even more impossible things. We might soon be able to look back 14 billion years and see a universe that looked just like it does now. This would mean that the Big Bang happened even longer ago, or that it never happened at all. It is certain that every new discovery based on actual observations moves us forward. For almost 100 years, things like black holes and the movement of galaxies have mostly backed up the old physics. But now things are different, and a time of change has begun. Our physics is stuck at a few levels, and this might be the answer. But something is still not right here. Very few people know that physics is now pushing the limits of what is possible in almost every area. Astrophysics has reached its limits with these galaxies and black holes that are very old and very big. Researchers don't know anything else about the world of the smallest particles. At the very latest, the tiny particles become so unpredictable that we can't understand them anymore. This is beyond Heisenberg's uncertainty limit. Researchers who are looking into the current structure of the large-scale universe are also confused. The more we look at it, the less the patterns and structures make sense with the Big Bang and the idea of the universe getting bigger. But what does all this mean? We are at an exciting point where new things will be discovered in both the small and large worlds, as well as at the start of our universe. It has been known for a long time that the physics of the biggest things can't be explained mathematically or experimentally with what quantum physics has found. But quanta are also what make up stars, planets, and galaxies. It's not because our universe is broken, that these two fields don't fit together. The researchers just don't know where the mistakes and connections are. The current crisis could be a great chance for science, but some of the most important people in astrophysics will have to leave their jobs. Now, scientists are arguing about who is right and whether they can stick to theories that have never been proven by observations. This is crazy. No one has ever really seen the Big Bang or the universe expand. James Webb is now revealing a little more of the truth, and it's hard to believe that scientists are still protesting in defending their clearly false theories. It reminds me of the Middle Ages when Galileo Galilei went to church prison for saying that the Earth went around the sun. But there is also good news. Young researchers like Rohan Naidu, a doctoral student at Harvard, are happy about the new information. There is a group of young and even older astronomers and cosmologists who are open-minded and have long thought that the old explanations were not enough. Naidu used his algorithm to find some of the oldest galaxies in James Webb's depth image. Naidu put the data from the depth image into his computer as soon as NASA made it available. Soon after, the feeling was just right. The old way of figuring out the red light shift said that the galaxy class C13 was 13.6 billion years old. This means that it was already there 200 million years after the Big Bang. And since this galaxy must be at least several hundred million years old, if not 2 to 3 billion years old, something is wrong. The discovery was the start of the crisis. People weren't sure about the redshift. People looked closely at James Webb's method and questioned Naidu's results. But the age of the galaxy was confirmed many times. The James Webb Space Telescope takes down the house of cards. The most well-known astronomer in the US is Michio Kaku, and he was very happy with the results. Kaku is one of the few people who really tried to connect quantum physics and astrophysics, and he sums it up. Webb is finally bringing down the shaky house of cards, that is astrophysics. Nobody saw the shock coming, because a lot of the older scientists were sure that James Webb would back up their ideas. So, will science reach a consensus or not? It has to, because the universe is honest. Right now, a lot of the new studies and discoveries are going through peer review, which is when scientists send their research results to other experts in the same field to be checked. This is where possible mistakes are found, and reviews often lead to clever new ideas and developments. We can be sure that researchers will be more careful in the future about what they tell us is true. The heresy of the Big Bang, which happened 13.8 billion years ago, is bad enough. Sir Roger Penrose, a British astrophysicist and Nobel Prize winner, said that because of the new situation, we need to go back to the point where we have reliable data and observations. In the end, this means that all theories that are based on dark matter must be thrown out, because we don't know if it really exists. This means that all of the previous ideas about the universe will be thrown out, and the universe will be looked at again. Let's take a look at another new astronomy star in the night sky that isn't as bright as the others. Since 2023, Euclid has been in space as part of a special mission. We are going to get the best map of the known universe ever from Euclid. James Webb is made to focus on one thing at a time, like a star, galaxy, planet, or something very far away. On the other hand, Euclid mirrors work in such a way that the telescope can see large areas and make maps of the whole universe that can be seen from Earth. This new information should help us figure out if dark matter and dark energy really exist and how they work, among other things. If researchers can't find any evidence for their existence in Euclid's data, it will be a close call for all the scientists who were sure these two variables existed. Press the subscribe button now. The best videos are yet to come.